Hi friends, in the previous class we have discussed about fluid motions. So how the fluid motions takes place from one place to another place whenever there is a fluid flow. And in this class let us see the fluid motions and when it is happening and what are the different types of flow occurs. So types of fluid flow we can just discuss in this class. So first of all, let's see about steady flow and unsteady flow. So the name itself okay, gives some understanding of what is meant by the steady flow, because the steady flow is nothing but the flow is steady. It means what? Whenever flow happens at some interval or at some locations, then what happens? It is not changing. The flow parameters or the fluid characteristics is not changing with respect to time. So that is the meaning. Steady means so it is always remains constant. So either it is 1 second or 2 seconds or 10 seconds or okay 100 seconds. So whatever it is for the different time interval, so the flow characteristics or fluid parameters is not changing with respect to time. So that is nothing but when you say that we have this. So if you just if you take it as this pipeline and it is, so here we have this, let us say this is section. At this section we are just denoting the or we are just measuring. So we are just monitoring the changes of the flow. If this flow parameters, say for this is pressure and temperature, density and velocity, so these parameters is not changing at all for different time interval. So at time t equal t t1, t2, t3 and like this tn. So it is not changing. That means these parameters pressure, temperature, density, velocity and all is not changing with respect to the different time interval. So that is what we call it as steady flow. Then unsteady flow is very simple. We just say that these parameters changes with respect to this different time interval. So always that is, we can just say that if you want to put it in this way, so just like dp by t is equal to 0. This is for steady and it is for steady. Then if it is not, that means dp by dt equal to 0, it is unsteady. So this is about steady and unsteady flows. So now let's talk about uniform and non-uniform flows. And uniform and non-uniform flow also can be just yes, with the help of this diagram we can. So uniform, what is meant by uniform and what is meant by non-uniform? So first let's take a pipeline, that means flow in the pipeline. So like this, so flow is taking place in the pipeline and now this flow whether it remains same, it remains same throughout the pipeline. So that is one thing. Or if you take two sections, if I am just taking one section 1 this and section 2 so if the flow parameters or fluid characteristics is not changing at a different space, at a different cross section, different space in the sense different cross section in this case. So in different cross sections, if the flow parameters is not changing, then we can, that is what we call it as uniform flow. So it means this is there are no changes in the fluid parameters with respect to the space. So that we can just take it as dp by ds is equal to 0. It means this P stands for anything. P equal to pressure and temperature and density and velocity. So like this. So this P is nothing but these parameters. So whenever we are having this condition, that means with respect to ds, that is the ds is nothing but this is what ds. We can say, if you want to say, this is ds. Change in the length, so or change in the space, that is what we say. So ds. So if there is no change in the fluid parameters with respect to this ds, then that is what we call it as uniform flow. If changes happens, then with respect to this flow parameters or within this flow parameters with respect to the ds, if the flow changes, that is what we call it as a non-uniform flow. Non-uniform flow is nothing but it will be changing from this location, this position, the flow parameters will have a certain value, and when it is coming here, and this will have a certain parameters in the flow. So that is what we call it as a non-uniform flow. So that means it changes with respect to space. So that's what. So this is about uniform and non-uniform flow. Now let's see about laminar and turbulent flows. So laminar flow, as the name indicates, the flow will be taking place in lamina. So like this, layer by layer. This flow will be taking place in layer by layer. So this one layer will not interact with another layer. So that is what we say. It takes place in the smooth layers and also will not interact with another layer. So then this type of flow we can call it as laminar flow. And also this flows in a smooth manner without any deviations in any channels or any other pipelines or anything. So then this kind of flow occurs at a lower velocity. That means very low velocity. If you have a we can just say velocities. So at low velocities we can just say this kind of flow will occur. So another thing is the laminar flow has a certain characteristics. So that is nothing but we can later on we are going to study about laminar flow. That time we will be understanding about streamline, because streamline also very important in fluid mechanics. So the streamline, how it is useful, okay, so that will be understood with the help of laminar flow. And because that streamline itself is based on the laminar flow, that's what we have to understand. So that means how the streamline is defined, so that we will see later. And then now the another type of flow that we call it as turbulent flow. Turbulent flow is just opposite to the laminar flow. So here we don't have any kind of this. So turbulent flow is unsteady. So when you say laminar flow is a steady flow, then turbulent flow will be unsteady. So it will be like zigzag. So it will be flowing like this, then like this. So it means what happened, that particles, fluid particles or the fluid layers interacting with each other. So one layer will interact with another layer. So like this there will be that means transport in properties. The fluid properties will be transported because of the interaction between the layers. So because of that reason it is not irregular. That means this turbulent flow is not flowing in the regular path. It will be flowing in the irregular movement, and also this will be interacting with each other. That means because of that it is highly circulating, chaotic. So that's what we say. So he or irregular. So this is very important phenomena that in the turbulent flow, because of that nature, the turbulent flow is highly unsteady. So that's what we say, because it's not it's highly unsteady. So because of this unsteady nature, so the fluid properties, that means it gets transported from one particle to another particle, or from one place to another place in the fluid flow regions. So that's what happening in the case of turbulent flow. So and then next one is called combustible and incompressible flow. Combustible flow. First, let's see about combustible flow, and then. So compressible flow is nothing but whenever we are having whenever we are having the liquid or fluid in the container, then what happen? We have the liquid. Let's say this is the liquid. So this fluid is, suppose now we are applying. That means there is a pressure. So we are applying the pressure. Then because of that reason, suppose if it is getting reduced, if the same quantity, if it is coming down, so if it is decreasing, then what we can say that the volume is getting changed. The volume of the fluid is getting changed. So that is what to say indirectly, if you want to say that the change in the compressible, that means change in the density. Because of the change in the volume, the density also changes. So density of the fluid also changes. So here it is higher density, and here it is lower density. So because of this application of the pressure, so what happened, it is changing. That means the volume is changing, because of that density also changes. So whenever it happens, that type of flow we call it as compressible flow. So this is nothing but compressible flow. When in change in the density, from point to point, that is also important, from point to point. So this is what we call it about compressible flow. So it just incompressible flow is just opposite. Incompressible flow is just opposite. That means there won't be any changes in the fluid density from point to point. So that means will be same. That means it remains. So the volume, suppose in the beaker, so we have the water. Then the water we are applying the pressure. So here we just apply the pressure, and then after some time, that means from any point, then it will be remaining same only. So it won't change. The volume does not change. Because of that change in the volume, no change in the volume, so the density also will not change. So no change in the density. So that's what about an incompressible flow. So these things we have to understand very clearly whenever we talk about compressible flow and incompressible flow. So now another flow is called, we can see about rotational flows. So that means nothing but rotational flow. So we can just say rotational flow. So what is meant by rotational flow? So rotational flow is nothing but that means suppose if it is rotating, if it is revolving, if the fluid particles revolve around the streamline, that means in the circular streamline, then we have a, let's say that we have a one kind of fluid particles. So this fluid particle, when it is coming here, then it will be changing. The orientation of the fluid particles will be changing. Say for example, this is A, this is B. Then when it is coming here, then it will be changing like this. So it is changing its orientation. So and then when it is coming here, it will be changing. So and it is like this. So this is when we say here, and it is A, this is B. and here it is again, it will be so A B and like this. So this is D. So that means in the rotational flow, the orientation of the fluid particles changes about its own mass center. Because for example, this is for this particle, the mass center will be here. This mass. So about its own mass center, it is changing. That's what we have to say. So about its own mass center, the rotation in the rotational flow, the fluid particle changes. So its orientation. So that is what we call it as rotational flow. Then irrotational flow, just opposite. That means the fluid particles will not. That means we can just say that will not change at all. That means the orientation of the fluid particles in the circular streamline, when they are flowing in the circular streamline, then what happened? Then we have the fluid particle. The fluid particle will remain as it is. It will not change. The orientation will not be changing at all. So this is what happening in the case of irrotational flow. So the fluid particles does not change its orientation about its own mass centers. That is also very important. When I say this is AB, this is also AB. That is what we have to understand. So this is also, this will be like this only. This is AB. So yes. So in all the cases or in all the locations, the fluid particles is not changing its orientation. So in the case of irrotational flow. So that means that it's not changing its orientation with respect to own mass centers. So that is also we have to mention. Okay. So this is about irrotational